right, thank you, Abe. Our next speaker is David Follen with ING Belgium. David is an IT enthusiast with more than 15 years of experience developing distributed applications, mainly in Java. His broad international experience covers telecom, retail, and mainly financial institutions. The last 10 years, he's been engineering solutions for the highly demanding banking environment. Please join me in welcoming David to the stage, please.
I'd like to thank Abe for the introduction because I'd like to present how actually ING is going through its digital transformation. I'll quickly introduce who we are, go about our challenges, and how we use in-memory computing to overcome those challenges. Quickly about us, we are a bank in many different countries, but mainly in the Netherlands and in France, in Belgium, where we have our 10 million customers. We have globally 36 million, but among those 10 million are from a relationship, meaning that they trust us to do their financial services. Our purpose is empowering people to stay a step ahead in life and business. And to do that, I'm going to focus today on one of our main customer promises, is anytime, anywhere. This has changed a lot in banking. Before, customers used to go to branches. They went there and all the data was flowing in the evening when everything was done. But now people want to access a bank account from everywhere, from tonight in the bar. They want to check if they have enough to buy a new beer, and at any time. And that changes a lot on how it impacts our existing system. So to be able to support that, we're going to have to increase the pace of innovation and focus on solutions that will help to fulfill the new customer needs and the ever-evolving changes. And also we need, as I presented, to think beyond banking. We need to provide new solutions, new business models for our customers. So, unfortunately, we are there for more than 40 years, or fortunately, you would say, but our main systems are based on mainframes, so I'm talking about our payment systems, talking about our customer information system, all of those rely on mainframes. And the application landscape in a bank is quite complex, and a lot of new applications are still relying on those mainframes. So migrating out of those mainframes is a very complex operation. Moreover, well, we have a huge increase in access of our services right now. So since Internet Mobile is growing, it's booming, it's exploding, people are moving out of the browser. They were going to a branch, and they use the ING application on the browser, and now they have that on their mobile, and they don't need to use that. And they're using it all day long, and even in the evening. The Payment Service Directive offers to third party the access to ING data, ING services. So it will help customers to use authorized companies to access the ING data. And that, therefore, puts even more pressure on our systems. And right now, to get all of this working together, our integration services, but it puts some load, and we have around 200 to 300 millisecond latency on our system. So that really doesn't help. And finally, we tried to scale up our mainframe, but it didn't work either. So why did we choose in-memory platforms? Well, resiliency, performance, scalability, but also other important factors, like it's open source, like Apache Ignite, but it has professional support, like GridGain, because as a bank, we can't focus on technology if it doesn't have professional support. In ING, we bet a lot on Java, so here it's helping. It's a promising technology, as presented, and also it provides a response time which is predictable, not like mainframe. So now I'm going to present the different applications that uses IMC in ING, but I want to warn you, we like our acronyms, so brace yourself. I'll start with SEPA Direct Debit, which focuses on compute and data grid. Then the multi-bank customer reporting, see often. the real-time gateway, shielding, and finally GridGain as a service. So SEPA direct debit. This is something that's been introduced by the Single Euro Payment Association. And here it's about allowing companies to withdraw money from your account once you have provided them the mandate to do so. Let's say, for instance, I have a house in France. Before, I need to open an account in France and so that the electricity company could withdraw money from my account. Now, with the SEPA initiative, I don't need to open. I can have my account in Belgium and provide the mandate to the electricity company, and they can withdraw money from my account. They can collect this money. So the users of this scheme are both the retail and the wholesale banking. And most of it is used, for instance, by PayPal. PayPal does a collection on your account if you allow them to do so. But also credit card companies and electricity companies, other internet companies, they will offer, you can offer them a collection and they will take the money from your account. So to be able to stay competitive in this world, we need to provide aggressive response time. So we need to be able to process the collection file that these corporate send us in a very short amount of time. And once this has been processed, we need to offer to our customers also the possibility to see what has happened on their account with different types of channels. And also offer this information through the PSD2 initiative so that other companies can access via our APIs this data. How do we implement that? So we receive files in ISO 20022 format. We're talking about payday here. They're fed through a Kafka topic. Then we use the Kafka streamer from GridGain to process those files. They are put in an intermediary cache. Then using in-memory computing distributed task, we take this information from the cache and validate it, put it in a permanent cache, and from there we have a transaction validation that will process this information. So we're talking about 5,000 files a day and about 16 billion transactions on a peak day. For regulatory reasons, we need to keep 14 months of history, which leads about 1 billion transactions in memory, and it's about a terabyte. So we need to have a very efficient platform to support this load. So you see here the payment initiation. We do that using the data streamer, and we put that in a data grid. Then the validation are done using distributed compute grid. Finally, the computation and the aggregation are also done using the distributed compute. And we offer services through our API using on those caches using Ignite client nodes. Multi-bank customer reporting. So this is aimed at wholesale client. It's to be able to give them the list of transactions that happen on their account, so that they can reconcile this information with their internal system. So for instance, our payment system sends information such as how many transactions have happened on a given account for a given period of time, let's say from 9 to 10, for instance, and we have a list of those in several files, volumes, or they're using the format MT9. Here, the application needs to gather all this information, merge it, and send a full report to the customer. So from the payment system, messages are put on an MQ. Then right now we have an old Java enterprise application. Once all the messages are parsed and put to the database, then stored procedure passes in the database. Once this is finished, they put on an MQ response queue, and they give to the reporting application that sends that to the customer. But here, the application that's existing is based on an old and deprecated vendor framework. It wasn't designed to be distributed in the beginning, so it's been hacked, and it's not helping, and it's not flexible or extensible. So that's why we've introduced GridGain and Ignite on this application. So now we use the power of the grid to compute, to validate, transform, merge all this information directly in memory, and that also gives us a scalable system. So if we want to add more processing power, it's easy to do, whereas in our previous configuration, it wasn't that simple. We also made a difference between the processing caches and the viewing caches that the UI can access. So here, we've put this application in place, also thinking that we shouldn't impact the existing system. So we put in the middle our Kafka bus and this grid, because also Kafka is the new standard in ING. So here, the load in the beginning is quite small, but it will increase a lot. And that's why we're really betting on in-memory computing for this. The real-time gateway. Again, an initiative from the Euro. Here, it's about the instant payment initiative. So the instant payment initiative is that when you make a transaction to your colleague, for instance, his account has to be, his or her account has to be credited within 5 seconds. Right now, with the SEPA credit transfer scheme, it takes about 2 days. It goes to EBA, there's a lot of complex interaction happening, but it takes about 2 days. Now we want to move to 5 seconds, which is a huge change. So to put that in Belgium, they've used a new vendor called Step. It's a French vendor. And all applications, all banks go through this vendor. This vendor uses MQ and ISO 20022 file format, which is standard. But our internal application at the internal payment system only works with fixed fields formats, and they work in COBOL. So we needed an application to be able to transform and connect sets and our payment system. So that's what we did. We've introduced this in-memory cluster in front of, between those two queues, one MQ going to the state connector, so it's an appliance deployed in the bank that connects to the state application, and our payment engine on the other side. Here, the cluster uses in-memory Ignite topics to move data from one state to another, for instance, from state received to parse, to validate, and so on. And everything is done in memory again. So this architecture provides us a better response time, and again, scalability for increase of load. Shielding. Shielding is, I would say, something we put in front of the mainframe. That's where we want to go when we want to move out of the mainframe. So it's an in-memory cluster that we put in front of the mainframe so that the application, they don't go directly to the mainframe, but they go to this in-memory cluster. So the data is offloaded in this in-memory cluster, but it has also different applications or different purposes. It's to provide a way of patterns on how to use data and how to store data in ING. And for instance, you could have a new application that stores this data in a grid, which is backed behind, for instance, by Cassandra or by Oracle, but the main access to the data would be the data grid. There's an in-depth presentation from my colleague Lieven Merks that was done last year at the in-memory computing in Amsterdam. I suggest that you look at it, it's very interesting, and it's much more detailed than this presentation. And finally, I'd like to talk about what we're putting in place in ING is GridGain as a service. So we are promoting the usage of GridGain in ING, and we have this ING private cloud, on which new application will be deployed. So it's an internal cloud that you can use as a developer, and you will be able to deploy new application quickly in this cloud. Here, what we will do is provide a Docker image that's based on Red Hat and GridGain, but also has on top of it ING minimal requirements such as security, monitoring. And here we're providing that to our developers, to our engineers inside ING, so that they can easily start a new a new GridGain project, a new in-memory project without any hassle. All the basic needs have been met for them. So we're talking about, yeah, also native persistent store, the distributed on the SAN, the network. Here, I have some customers that are going to use it, and it's very important to see how ING is fitting in as in-memory computing. So what should we take away from this? Well, as I presented, it's a change of mindset. It's not the same application with a basic database or DBMS. It's a different way of thinking. We have to move out of this, and it's still new. There's not a lot of IMC engineers available on the job market. It's pretty hard to recruit people. But it's a promising technology, and we're exploring different use cases. We're even using it where the notion of load is not that important. We have a low load, but it's to experiment, to see how we can use, how far we can go with in-memory computing. But again, it's still evolving. We had issues in the multi-tenancy application. For instance, having different applications with different life cycles run on the same grid didn't work really well. So we had to find other ways to do it. But here, it's still in infancy, it's still learning, and we have a lot of trust in the future. And also, we had created an infrastructure on top of GridGain, but this didn't work. And I wouldn't, the problem was, it's like every platform, every framework. If you don't use it for the way it's been intended to, it's not going to work. And that was something we did wrong. So yeah, I'm definitely looking forward to the talks today and this afternoon. I think it's going to be interesting to see how you guys are using in-memory computing. And thank you for listening.